Okay, here's a big question. It's all involving a second order equation. So it says that 2 iodine goes to 2, the I2 gas, and it tells you what the rate law is. And so the rate law is second order. First thing is that it asks you for the units of K. And remember that the rate must always be molarity per second. And so we know that whatever the units of K are, that when we multiply it by this concentration of iodine squared, that we'll get molarity per second. So you have to ask yourself what units in here would get you molarity per second. Well, if I have molarity times seconds and I multiply that by molarity squared, then one of the molarities there cancels, this one cancels, and I'm left with molarity over second. So what are the units of K? They're 1 over molarities per times seconds. Okay, second part, part B. If I naught equals 0.4 molar, calculate the concentration of iodine after 25.3 seconds. Well, it's a second order equation. And so we need to use the second order integrated rate law, which looks like this. And it gives us everything we need except for the concentration at that time. So the rest we're just plugging in. So we got 1 over A at time t, that's the one we're looking for, 0.0754 per molar times seconds. That's the rate constant. It tells us the time we're looking for, 25.3 seconds. And we know the original concentration is 0.4 molar. So when I do some simplification, I get that 1 over A at time t, that's the concentration I'm looking for, equals 4.4076 per molarity. And when I take the reciprocal of both sides, I get that the concentration is 0.227 molarity. And that's the answer for B. Okay, part C is if the initial concentration of iodine is 0.4, calculate the half-life. Now, we can take the same equation that we started out with for part B. The only difference is instead of knowing the time, we don't know the time anymore. But now we do know the concentration of A at time t. Well, it's exactly half of the original starting concentration. So half of 0.4 is 0.2. Okay, and so now we're just solving for t. So when we simplify, we get 2.5 per molarity equals 0.0754 per molarity times seconds. That's the T1 half. So T1 half equals 33.2 seconds. Okay, last part, part D. How much time would it take for 75% of the iodine atoms to react? So again, it's just like the half-life question in that we know the two concentrations. Well, this one is 75% of the original concentration. And so I start to work towards that. So then that must mean the original concentration was 100. And I can just use the units of molarity in order to get it there. And so I can set, oh, I'm sorry. It tells us what the concentration was. It was 75% of 0.8. That would have certainly worked. Or we could say 75% of 0.8 is 0.2. We get the same answer. And then I get the time for that is 49.7 seconds. And that's the answer there. Okay.